So, yeah, I think it would be good. So before we chat about governance and seeing like a blockchain protocol, I want to say one piece on next week and the second. What we're going to chat about today is what seeing like a blockchain protocol means. Talk about governance a bit, governance in the blockchain setting more specifically. We're going to do like a blockchain governance simulation, and then talk about the ethics of blockchain governance. I do want to say next week, so I have been messing this up. There is class on next Monday, and Tuesday is open. It's the recitation time is, sorry, let me be clear. Initially the plan was to have Jason and Ellie come and chat about their expertise next Monday's recitation session, but it's a school holiday, and so we will not be doing that. So we'll push it off one more week, essentially. So there will be no recitation on Monday.
Recitations are optional, right?
Optional,
For your
yeah.
class, they're not.
Yeah.
But Jason will be there next week?
Yeah. Yeah.
So absolutely no recitation or no session?
No, next Monday there will be nothing. If you come here, I will not be here. The other note is I'll send out a feedback form to all of you, and I really, please, so we're about halfway through the semester-ish at this point, and so please give me your feedback here. I think it makes sense to make it anonymous this first time, yeah, I think we'll make it anonymous this first time, and let me know, please, though, give me your brutal, honest feedback, so I'll send that out, and please, like, take 30 minutes to do it. As a reminder, now that your proposals are in, each week there's these weekly updates that you start to send in, and so those are, you can either send them through that Google form or through email, and what they look like is this, for you to say, hey, here's what happened this week, here are things that like were cool this week, here's like what I learned, and like, oh man, I didn't expect this, maybe here's some folks I chatted with, and then like next week I'm hoping to get this accomplished, by doing these specific things, and like, Reese, can you help me with XYZ or whatever. So that's what these weekly updates look like, and they're just every week say, hey, here's what's happening, I'm still, trudging along or whatever on my my project. That's what the weekly updates look like. Are there any questions on that?
Can you build the weekly updates into your project? For example, for my project, I would like to do a series of blog posts that are like talk about different aspects of my project.
Mm-hmm.
Can those serve as my updates, since they are in some way keeping me in track?
Yeah, that sounds. I will answer a tentative yes, and then if I see the blog post and it's like not, if it's not doing this kind of stuff, then I would say no. But I think the yes is probably the answer.
And which email do you send these into, and like what day of the week are they due?
They're due Thursday at 2:59, so right before class. And you can send them. There's either the class that like Google form that you can always add links to, or you can just send them to the blockchain instructor's email. Any other questions? Cool. And then as a note, as a reminder, everyone, we are going to do these presentations, these like halfway test presentations in 3 weeks. So that's kind of what you're ramping up towards. And at that presentation, it will be kind of a test for your final presentation, and also letting everybody know, hey, here's what I'm working on, here's the stuff that I'm interested in, here's what I've learned thus far, that kind of thing. And so that's happening in 3 weeks, and you can see what that looks like on the syllabus as well. Cool, any other questions on this? Alrighty, so let's chat about seeing like a blockchain protocol. And this phrase, seeing like a blank, is taken from this book called Seeing Like a State. Has anybody read Seeing Like a State?
I'm like
Yes,
reading it right now.
yes, okay, sweet. I like this book. It's all about how certain schemes to improve the human condition have failed. The idea behind it is the state as an institution has a certain, when it tries to get things done and tries to like improve society, it can only do so in a way that like the state can see what's happening. And so what happens is you get these things where, so for example, this is like a normal natural forest, and then the state tried to take that forest and they said, okay, we gotta make this more efficient, we're gonna make it look like this, everything's gonna be in these nice gridded rows and stuff, and it'll be awesome. And then they did this, and it worked okay, but really it was a lot less. It was a fragile system where then there were issues with like carbon in the soil, and there were issues with like if fires go through here, and there's all kinds of issues that you said, hey, once we do the state thing and turn into this nice grid, it didn't really work out. And so, but it's tough for the state because the state, the state, it's like illegible. The state doesn't really understand what's happening here, but for this is like legible to the state. So this concept of legibility is crucial. And then over here you can see similar things. This is this place called Brasilia, maybe folks in Dusk know it. Yeah, Brasilia is an idea where you are, it was this new town that they were going to create, a new city, and they're like, let's create this awesome new city, and it's going to be awesome. And from the state's perspective, to make it legible, they need to make all these grids, and they need to say, okay, people are going to do things in this way, and they're going to love their experience with this. And they created it, and it didn't work at all, and everybody hated it. And it is like an example of bad top-down, kind of seeing like a state planning versus kind of a bottom-up, what do the people feel in the situation kind of stuff. So that's what seeing like a state means.
The other master's student in our group is from Brasilia. She's an architect, and she might disagree with you.
Oh, really? As in she thinks Brasilia is cool.
I mean, she loves where she's from.
Yeah, that makes sense. That might be hard as a city planning student, or like, I don't know very much about city planning, but it seems like people don't like Brasilia.
I hate it.
Okay.
I know like one of the first things that happened when they finished building it was that like they were expecting like it to be this like clean utopian city, and then like they got all this cheap labor, and when they were done building the city, they like just like built favelas around it, and like the government didn't really want that, but they didn't really have anywhere else to go. So little things like that like made it less utopian than the state wanted. Like they had all these cheap labor, but they didn't know what to do with the cheap labor after they were done building it. They're like, well, this is ruining my pretty city.
Like, oh, you go outside.
Yeah, exactly.
Yeah. So in any case, that's what people mean by seeing like a state, and it can be applied to other things, like seeing like a face, like a Google, like a internet aggregator, and like they see the world in a certain way based on their incentives and stuff. And so what we're doing in this section is asking this question, like what does it mean to see like a blockchain protocol? So that's kind of the macro driving question here. What are the ways that the blockchain protocol tries to make things legible, illegible, how do norms work within it, how does code work within it, etc. So, talking about governance generally, how would people define governance? Does anybody have any thoughts on like how they would define what governance means?
Just rules by which an organization or society run by, like.
Yeah, I mostly agree with that. Would anybody disagree with that or add to that? I think it's pretty good. I think there are the rules piece, or this is from Wikipedia, the process of interaction and decision making among the actors involved in a collective problem that leads to creation, reinforcement, or reproduction of social norms and institutions. I do think this has an additional key piece, which is that's like you have all these actors that are on this collective problem, and the institution's kind of reproducing itself, and they are like governance is the act that does that. And the other key piece for me is this these two pieces of sense making and decision making, where governance is the process of not only making decisions and like the rules there, but also how to determine what the information is, and then from that information to make some decisions, and then after you make some decisions, then you do some more sense making to see how that went, and you keep on doing that loop. So this combination of sense making and decision making is, I think, the two big buckets of governance here. And as we know, pretty much almost all institutions have a form of governance to them. A government has governance. And like in the US federal system, you have something like the judicial, the legislative, and the executive is an example of like what governance looks like for that. And other things that exist, like the internet, also have governance. And so this is a kind of complicated graph, but it says who runs the internet? And it is weird because no one person, company, organization, or government runs the internet. It's this weird new online thing. And so you can kind of see they just map out these 4 steps here where you have multi-stakeholders, a bunch of different people are trying to say like, hey, I want this, I want that. they kind of debate each other for a while, what should happen, and eventually those things turn into policies and standards that then they implement, and then like operations happen, and the things get implemented. And you have a bunch of these are all different agencies that exist to kind of keep this thing in check.
So what does it take then for those policies and standards to be adopted in real time? Is there like a timeline that often?
That's a good question. So, for example, there's I think a good example of this is the internet, the IP protocol that it used to exist, IPv4. There's this new one, IPv6, and V4 is version 4 and V6 is version 6.
We skip 5.
I don't know why they skipped 5, but yeah, I think so. And I think the main difference is just that it's just the amount of bytes that's available. I think there's some other.
It's the size of the IP address, so
Yeah.
they wanted a big size, like big space.
More
for-
bytes.
yeah.
And it's really funny because like all they're changing is just like, okay, let's add some bytes to this thing, let's add more space. And the process has taken a long time. I think it was initially proposed in 1985, and then there was I think there was 15 years of discussion around it until the spec was formalized in 2001. And then I think it has, over the last 20 or so years, you can see IPv4 versus IPv6 and what percentage of internet traffic runs on them. And IPv6 I think is still below IPv4 with like maybe 30% or something of it. So this is to say that is an example of what internet governance looks like, and that's happening between all these different groups of IETF and W3C and etc.
One thing that I wanted to say is like when the first question came, what is governance? There's rules that someone sets up, and then there's incentives and punishments along with it. So in the internet scenario, what happens is they publish standards. No one's kind of obliged to follow them, but the incentive of following them is they kind of make it reusable, and some other people can connect to it. So if you're using, for example, a REST API, that's just a standard. It's like if you want to follow it. So the benefit is that other people also can start using it. So that's the incentive. The punishment is if you're not following it, then you become an internet explorer, and then people kind of just an example.
Yeah.
So there is kind of an incentive and punishment model, and there's rules/policies in the internet world.
And I would say there are positive reinforcement and negative reinforcement incentives across all of the different. If we think about those 4 big buckets of Lessig's pathetic dot, then I think there are norm-based incentives, where it's like, oh, if you're not using a REST API, we shame you, or / we give you positive reinforcement. And there's like market-based incentives, where you're like, oh, if you're using a REST API, you're more likely to be to have money flowing through your system stuff. So I think I agree with all that, and that there are positive and negative reinforcements across each of those different categories. So this is who runs the internet? It's kind of a weird thing because it's this bottom-up thing, and but it happens, they run it. And there's also weird parts of internet governance that exist. This was a thing, I guess, written in 1992 maybe, or and it was part of the IETF, which is the Internet Something Task Force, which is a group that is part of one of the standard-setting bodies. And a big line for them was, hey, we reject kings, presidents, and voting, and we believe in rough consensus and running code. And so this is weird because, like, if you think about how traditional, whether it's how nation states are governed or companies or whatever, companies have their board of directors, or nation states have their 3 different branches of government or whatever, and how the IETF runs is with rough consensus and running code. And what that means is that they try to get a vibe for, like, are people like cool with what's happening? And as that's happening, then they're like, okay, if it is happening, we're just going to code it up. So that's what we're going to do. Is we're going to test out experiments, we're going to do things, we're going to run code, and then get consensus around it. And they do this very strange thing where they hum with each other, where they, instead of voting, they say like, okay, what do we think about that? And then they like check the volume or something. I don't know. So that's what it means by rough. It's like real, really rough. The emphasis on rough. Yeah.
If you have a big hum.
If you're a big hummer, you're actually not going to get more of a vote. So that's kind of an example of some of these weird internet governance and how that works. And then there's also, in addition to like the base layer protocol of the internet, there's also open source software governance. And this is under this bucket. We've done this reading, I think, for last class of commons-based peer production is usually what people say for this, which was talked about by this guy Yochai Benkler, who's at Harvard, in this book, Coaches Payment or Linux and the Nature of the Firm, where you see these new kinds of open software projects like Linux and Wikipedia, and how they, in a peer-to-peer fashion, can kind of do their sense-making processes and do their decision-making processes in order to actually make stuff happen, like something crazy like Wikipedia. So that is what governance is in general. It's the sense-making and the decision-making processes within these institutions to propagate through time. And we have the traditional top-down systems, but then we have these new weird bottom-up systems like on the internet and with these open source projects. Are there any questions, by the way, on that or comments? Cool.
What,
No.
what does COAS have to do with the Linux?
What COAS has to do with this is what Benkler's argument is that we are seeing a new kind of institution which is different than a firm and is different than a market, and it's this new kind of thing that he's going to call commons-based peer production, and that thing motivates and coordinates people in a different way, and he went into arguments around stuff like transaction costs and, for example, information search costs, and how it was in these new open networks, the search costs are very low for people to kind of like find what they want to work on and then start helping with it. So that's the connection he was making. Does that make sense?
Right before Wikipedia, wasn't like Microsoft trying to create like the new like Britannica encyclopedia of like for the computer, and it was going to be really expensive. Then Wikipedia came out, and like it became obsolete because of COAS's Penguin, where like they're like it was just like a lot easier for people to just like add their own stuff through Wikipedia, and then get it for free than it was to have one centralized entity try to record everything and then like charge people a bunch of money.
Exactly. They leveraged the crowd and it worked. Yeah, so one final note on that, it's funny, Wikipedia, back when I was in high school, back in the day, Wikipedia was not trusted as a source, and now YouTube uses Wikipedia as a trusted source to debunk conspiracy theories and things. So the crowd wins over time, but at the beginning it's not trusted. So let's talk about blockchain governance. I think that when we think about blockchain governance, we have the same issue that we have with some of these bottom-up systems like internet governance or open source governance, and it's this idea of the tyranny of structurelessness, which is this woman, Jo Friedman, who was part of feminist groups in the late 60s, early 70s, and she was talking about how in those groups they were like trying to get rid of the ideas of hierarchies and things like that, and she was saying, hey, I'm just going to read the quote, but like, contrary to what we would like to believe, there's no such thing as a structureless group. Any group of people of whatever nature coming together for any length of time, for any purpose, will inevitably structure itself in some fashion. The structure may be flexible, it may vary over time, it may eventually unevenly distribute tasks, power, and resources of the members of the group, but it will be formed regardless of the abilities, personalities, and intentions of the people involved. The very fact that we are individuals with different talents, predispositions, and backgrounds makes this inevitable. Only if we refuse to relate or interact on any basis whatsoever could we approximate structurelessness, or could we approximate structureless. And that is not the nature of a human group. So, yeah, what she's saying is when you're trying these new bottom-up systems and you're trying to get rid of hierarchy, you can get rid of it in the traditional sense, but then it will kind of start to manifest itself in these kind of implicit ways. And the argument, to some extent, that she was making is that when you have these implicit power structures, you should try to make the implicit explicit and be like, hey, it's taking down the hierarchy is okay, but these new power structures that will exist, we should name them. And you can see this with things like, there are some interesting things, like with stuff like Occupy Wall Street and what have you, this kind of stuff comes up a lot, where it's like, okay, we're like taking down the man, and you're like, oh shit, like we're at this park, and like how do we propagate messages through the group? Who gets to speak? Who gets to tell other people that they can't speak? All those things are very difficult when you try to take that down.
One of the things that I found interesting about that was that there was like some anarchist groups that tried to take her like advice and try to like implement some of the things she recommended. I was wondering if you knew exactly like what they try to implement, because that seems like counterintuitive to like the anarchist kind of.
Interesting. I don't know that much about that. What I mainly know is that there's a lot of work being done with groups based off of like Occupy groups and nonviolent protest groups and open source software groups that are trying to create new tools for bottom-up sense-making and decision-making in a better way. So I'm not sure about those specific anarchist groups, but sorry. I'll ping me after class and I'll see if I can find that.
I think it was like in that Wikipedia article that like talked about it.
Okay, cool. Yeah, I'll check it. So this is the issue, and so what happens? So we're gonna go through an example to kind of look at how this plays out in real time. And so there's this Bitcoin block size debate, and I guess who all with a thumbs, this being like you really know this debate, you followed it super intensely, and this being like you've never heard of this debate before. Where are people at with understanding this situation? Okay, cool. Yeah, so pretty much not much. So what happened? This was a pretty big deal, and people were wearing right when I was getting into blockchain crypto like 2.5 years ago. Everybody was wearing these hats all over the place. Everybody on their like Twitter profile had this like no 2x thing. Like I had no idea what was happening, and there were people all around the world that were like meeting in groups to chat about things. This is like all of the Bitcoin core or a bunch of Bitcoin core developers and like a bunch of the mining power in the world, like all in one room, like trying to determine what the hell to do. And so the question, it was a big debate over, especially from 2015 through 2017, and the question was, how should Bitcoin increase transaction throughput? AKA, how should Bitcoin scale? And there were two big options essentially. Should Bitcoin increase the block size? And so what that means is right now Bitcoin blocks are 1 megabyte, and so you can only get like 7 transactions per second or whatever. So there's a pretty easy option to say, oh, let's increase it to 2 megabytes, and then you get 14 transactions per second. And so that's kind of on one side, it's like increase the block size, and on the other side is implementing this thing called segregated witness, or SegWit, for this thing called Lightning Network. And Lightning Network is another way to increase transaction throughput, where instead of increasing the block size for on-chain stuff to increase more things on-chain, you instead essentially go to this off-chain thing called Lightning Network, do a bunch of the transactions over there, and then occasionally settle them back to the main chain. So it's kind of like a more technical. This one you essentially just change a number. This one you have to like make this other change that allows for this Lightning Network thing to exist, and then allow for these off-chain scaling things. So that was at a high level what the debate was.
So I'm familiar with Lightning, but I'd also heard that Plasma was sort of the same thing, but for Ethereum. But so I'm curious, does Plasma kind of work the same way as Lightning then?
Good question. So there's a whole bunch of things in this bucket of off-chain scale. So in general, there's a bunch of people who are thinking about how to scale these networks. And when you want to scale them, you can do it in a bunch of different ways. And one of the main ways is with off-chain scaling. And Lightning Network is essentially the first version of off-chain scaling, where you say, okay, we're going to do all these transactions over here. And then there are a bunch of other options. There's Plasma is one of them. There's this thing called ZK Rollup. There's Plasma. There's ZK Rollup. There's I could name probably, and they all have just little bits of difference in terms of how they implement the off-chain scaling piece. So I would think of Plasma as essentially a variant on Lightning Network that's being experimented with in Ethereum. That's not how. But the way I really think about it is that there's 10 plus, likely like 10 to 30 different experimental projects that are happening with off-chain scaling right now, and none of them are really doing anything. But the experiments are running. So this is what I said before, and there's some pro cons here where it's like, obviously the pro with increasing the block size that you get more, you just get more transactions per second, which is sweet, and it's a pretty easy change. Easy-ish. It does require, and we'll talk about this in a second, but it does require an actual fork of the system. But the cons is kind of a short-term solution. It's like if you increase to 2, should you then increase it to like is 4 later, or like what should your numbers be there? It's tough to say. And this big one that people are against is it decreases decentralization. And the idea here, does anybody have any instinct for why making the blocks bigger would increase decentralization?
Because the miner now has more power which transactions to select. I mean, more power with the miner, basically.
That's an interesting thought. So yeah, you're saying a miner has more. I would actually say the opposite of that, which is if there's a small amount of transactions, then the miner can choose. If there's a bunch of different transactions, the miner could choose a very small subset to go in that 1 megabyte block. Versus if there's tons and tons of transactions, if blocks are super big, like 100 megabytes, then the miner has to put them all in. So that's not actually the answer. Does that make sense? Let's go over here.
Of the giant pool of transactions that are recorded, the distribution of where they are recorded or who decides which ones are recorded in a block in what order is more centralized.
So you're saying the and by the way, that pool of transactions is called the mem pool. By the way, so it's like when you do transactions, they first go into this mem pool, and then the miners choose those transactions from the mem pool, and then broadcast them out into the blocks. And so, Alex, your point, say your claim one more time.
Of the giant pool of potential transactions and then pool of transactions that are recorded, the place in which they are recorded is more centralized. So if there are like 100 transactions, instead of them like 20 being here, 20 being here, 20 being here, and 20 being here, it would be more like 50 here, 50 here, and you could consider that more centralized in terms of looking at a decentralized network of who determines what transactions in what block.
Got it. Yeah, that's interesting. So what I'm hearing you saying is that if each block back in the day when it only had 1 megabyte, it had 1 megabyte from here, 1 megabyte from there, 1 megabyte from each different person. But then if you have 10 megabytes or whatever, then those things come just from one person here, and then eventually one person over there, one person there. Is that kind of what you're saying?
Yeah.
Yeah. That's kind of it, but Jason.
So, question: what is the impact on like signing, verification, mining when you change the block size? Presumably, it impacts computational resources needed.
It impacts computational resources needed, and actually, so I'll just
What
give
way
you.
does it, if it's significant?
So the way that your question is, how does increasing the block size change how mining works? Essentially, is that your question?
And verification.
And verification. Yeah. So it's actually in the mining versus in general with these networks, thinking about the miners versus the nodes is the key difference here. With the miners being the people who are running a bunch of servers, taking the mempool and then solving the hard math problem and sending that to the system, and the nodes are just normal folks, and they're like 10,000 nodes or whatever in the Bitcoin network, and those are people who have to they're not doing any of the mining, they're not solving the hard problems, but they are when there are new transactions that come in, they need to essentially validate all of them. So they say, okay, here's 1 megabyte of new transactions, I need to validate all of these. And that is the worry, by the way, for folks with this. It's not really on the mining side as much. It's more on the node side, where people are worried that if you increase the transaction size, space, the block size to be let's call it 10 megabytes or whatever, then you can imagine, let's call it 100 megabytes. Then the only people then more and more transactions can essentially go into each block. And then instead of being able to be a normal person that just runs a node on their laptop, instead you have to, with these huge megabyte transactions that are coming in, you have to have more intense technology in order to run it. So it essentially increases the cost to run a full node, which decreases decentralization. Does that make sense?
But
Just to make
it goes faster.
But and I would say it goes faster, yeah, that means that each block can have more transactions. So, yes, the amount of the throughput is more. Yeah.
One question, just to make sure, node, when you say node and when I say miner, they're the same thing, right? Or when you say node or miner, they're the same thing?
Different things.
Okay.
Different types of.
Okay, so there's confusion. And the second thing, to increase the throughput, you would actually need more technology implementation, right? Is there a way that you can increase throughput without having the limitation on the CPU?
Yes, I think so. On your first point on node versus miner, imagine the nodes as users that are just normal folks running the Bitcoin software on their computer. And what they do is instead of, and they probably like hold their Bitcoin on their computer, they're running the software, and that software is essentially taking, it is watching the world for new transactions that are being broadcast. It's taking those as input, and it's building up its blockchain on its side. That is different than the miners who are both taking all the new transactions as input, and they're the ones who are solving the hard problems, doing the mining, and then broadcasting those to everybody.
This is an interesting point about throughput. Sorry, just to recap what I think I understand about throughput, is that Bitcoin was designed so that there's a new block about every 10 minutes. So then if there are more transactions allowed in a given block, you're increasing throughput because more transactions can then be reported every 10 minutes. But I didn't realize that there was a limitation to block size. Like how did people initially think that this was going to work with more transactions? Did they think that like there would then be this extending queue of transactions waiting to be processed because they couldn't get into that 10-minute block interval?
So isn't there like an OG like email thread of like the mailing list? It was either Satoshi or Gavin or
After
like,
Satoshi did his first post,
yeah, he's like, we're gonna have scaling problems
then the
in the
next
near
response,
future.
yeah.
Yeah, like that was like the first response. Oh yeah, Taj always puts that in his Lightning Network like talk, right?
I think the expectations were that like, layer 2 things such as Lightning were going to sit on top of like Bitcoin.
And the
So, I also have a comment. So,
Like layer 2 is the off-chain stuff that he was talking about.
Well, would it like collate additional transactions or smush them into single transactions?
Yeah. So instead of like if we're all like, let's say like if we're all like trading money with each other on the Lightning
Right.
network, instead of having to like have every single transaction on like the blockchain network,
So it would
we
reduce
just
the
like
total
we
number,
just
yeah.
keep a counter, and then at a certain point we're like we're just gonna condense it all to like this is the end result of like our current transaction for the past week, and then we publish that on the blockchain network, on
Makes sense.
Bitcoin network.
and I wanted to add that these are two different things, block size and the amount of time it takes to produce a block, because the amount of time it takes to produce a block depends on the complexity of the problem.
I understand, but
Right.
yeah.
So they're
But
independent.
putting the two together
Yeah.
does then limit.
They're not like exclusive from each other.
Mm-hmm.
And I think that they are, as far as I understand it, the 10-minute thing is something that decreases the amount of forks that happen. And something like Ethereum, they have blocks come out quicker than every 10 minutes. It's every like
15 seconds.
15 seconds, thank you. Yeah, every 15 seconds, and because of that, they have more uncles, which is a term for just like you saw a block coming in over here, and like someone else over here is already starting their new chain because they solved the problem. And so the 10-minute rule allows you to have more of just like one single heaviest chain instead of some of these like uncles happening. And I think there's that number, and that number is different than the 10-minute number, and is different than the 1 megabyte number, and when you combine them, that's when you get 7 transactions per second as the throughput of the system.
Can you repeat the sentence about like why decentralization comes last?
Yeah, and I'll just put it on here. So pretty much imagine it's like if you have a bunch of nodes, and back in the day, the nodes were able to, the total size of, essentially, if you can imagine 1 megabyte blocks, then every 10 minutes you have a new 1 megabyte block, and when you have your computer's waiting for them, looking for them, and when it comes in, your computer says, oh, here's this new block, it has to do a bunch of cryptography essentially in order to like check all the little proofs and things in there, and then it adds it to your blockchain on your computer. And if you imagine, and each of these is just 1 megabyte, if you imagine instead that this thing was, let's call it 100 megabytes, then your computer, when it wants to, as a node, when it wants to create this blockchain, these things are essentially just too big for it. As stuff comes in, it's just like, oh, here's another one. I haven't even finished looking at the old one yet. You know, like, and you've given me a new one, and it's like, it's so much new stuff, and then also, it's likely to, so does that help?
Yeah, so then, okay, so now you have to do more. So how does that get to the?
Sorry, and how that gets to decentralization is that then what the requirements, so essentially if you like, computer requirements are up. Computer and like CPU requirements are low here, but they are high here. And so then instead of 10,000 people being able to run those, you might only have, like 100 people being able to.
Because of
floating in space that's not.
And not 100 people because like they can do most of the transactions, like less people can use it.
Like my computer right now could run Bitcoin, but in this situation it wouldn't be.
The size of it
In,
is the
okay,
number of
because in my head, I would have thought that more people would decide to do it, but it seems like they can't do that because the block has to be done by that computer.
Yes.
Yep, the transaction taking new blocks as input, the computers have to run the watch for that and pass it to their blockchain.
Yeah.
That's like the
Yeah,
max.
so each computer has
That
to
like
check all the new
you increase the size, then it's the same rate,
I think it was
but more
random
transactions.
choice.
It's not attached, it's like
10
10
minutes
minutes
in 1 megabyte were just random
I thought you
choice.
guys were saying that the block rate will be affected if the block size
Make
increases.
it that much more decentralized, but then you have to fork.
No, the block rate stays the same.
And then there's a
By increasing the block, you're increasing the transaction rate.
Yeah, yeah, that I understand.
Okay, so,
I'm fairly skeptical.
thank you for
this is ever gonna exist and work.
that bonus combo. So, and this was,
Yeah,
oh, you're good. This was one of the, so this was a con that people saw was like, okay, if we just increase the blocks really big, maybe it's a slippery slope problem, we could get to lots of bigger blocks later, and it would decrease the decentralization of the network. And the idea behind Bitcoin is not necessarily, this is back to the 5 camps of crypto piece. This is in the heart of a battle between the store of value group and the sound money group and the internet payments group. Where the internet payments group is like, whatever, if it decreases decentralization, we don't really care. There's going to be a lot more throughput so people can actually use it as peer-to-peer cash. While the other group is like, no, this needs to be censorship-resistant sound money, and like that is actually what we want here. So it's kind of a battle between those two groups. Implementing SegWit, the pros are there's no real sacrifice for decentralization, and the cons are, I mean, it requires this new kind of weird technology, SegWit, which is very difficult to understand, and with this new thing, the Lightning Network, which is this untested technology, so it's kind of like a lot of technical risk here with this piece. So in any case, this debate was happening, and you have a bunch of these, you don't really need to go through all these, but there's a bunch of, in these networks, you have all these different stakeholders who are trying their best to battle here. You have the developers, you have the miners, you have the users, and you have like the companies and exchanges, and they all have their own kind of set of incentives. Almost all of them want to increase the value of their Bitcoin. People like developers want to they have their social recognition, they have to want to maintain power over the future direction. The miners want to, of course, increase their value of their current ones, and they also want to increase the value of their future ones because they have a lot of money in their miners. They want to make sure the future money is going to be good. The users also want to increase functionality. They want to be able to use it. And then the companies are kind of similar. They want to increase the future functionality. And so when all this group was happening, then they did some sense making to try to figure out what should we do here. And so they did it with a bunch of different things. This conference that exists now called Scaling Bitcoin, which happens once a year, maybe twice a year, started because of this. But you're like, hey, we need to know how to scale Bitcoin. And so they had a first couple meetings in late 2015, I think. And then, and so people were just getting together in a room and chatting about it. And this was some of the first times when the developers had ever chatted with the miners in the system. And this is a picture of a bunch of Bitcoin core developers and a bunch of the mining power. I think probably I wouldn't be surprised if 90% of the mining power is in this picture, and a lot of very powerful Bitcoin developers. And there's Corey, the person with DCI. And so, and then people were getting together in groups, and another big thing where people got together. This happened in October 2016, and they made an agreement, the Hong Kong Agreement, which was to essentially do both of these things, was to increase the block size to 2 and implement SegWit. So this is called SegWit 2x. So it's like, let's do both, which makes sense for what you would do. But then when they did that and they implemented it on the network. But then the miners just didn't do it. And so you're like, what's going on? And so they had this other meeting in May 2017, and this was just a group that got together that didn't actually include any of the Bitcoin developers. And so it just included a bunch of big companies, and they made this agreement. That got a lot of pushback because people were like, no, like the Bitcoin core developers, like, we don't actually like what you agreed to here. Actually, it was the same exact thing as they agreed to here for all the differences. But by this point, like, the situation had changed, and so they're like, and they also want to be part of the conversation. But these in-person meetings are super, or one important piece, there's all this like, online conversation and like technical understanding. So in April 2017, so after they said let's do SegWit 2x, they tried to, and they like said, okay, now miners do SegWit, and they didn't. They were like, why aren't they doing this thing? And it was because this guy Gregory Maxwell, who's like one of the Bitcoin core developer, in April 2017, he learned that the miners were doing this thing called ASIC boost. So he got one of the miners, actually one of the like pieces of hardware, and like did a bunch of tests on it, or looked at the mining software or some combination. He said, oh, this ASIC boost thing, if they use it, it would be incompatible with this version of SegWit that they were planning on doing. And so he said, hey, an incompatibility would go a long way to explain some of the more inexplicable behavior from some parties in the mining ecosystem. So it was like, okay, we did this thing, we thought you guys were down, and now you're not. Oh, it's because you've you put a bunch of money into these ASIC boost things that wouldn't work with this. So we would essentially lose you a bunch of money if you if this thing actually went live. So this conversation is happening online about technical things. Then there's a bunch of polling of like influential stakeholders. So on the left side over here, there's a bunch of like the Bitcoin core. In general, it became like the Bitcoin core developers versus the miners / exchanges. And so here's a bunch of they started asking people like, yo, what should we do? And you can say like, LOL.
Nope.
And so exactly. So you can see that a bunch of these folks, these are just like different implementations of like how to get SegWit into the network, how to deploy it. And then this is like, oh, should we do it with 2x? Like do it while we increase the block size by 2. And all of them are like, nope, we don't want to do and
these are people's names.
These are humans, yeah. Or some of them, except for like Nopara73. Who's that? I don't know.
They're not all real names either.
Yeah, I bet most of them are real names, but definitely some of them are probably not. And then you have these companies over here that are both wallets and mostly wallet exchanges and miners. And they have, for SegWit, a lot of them were game to do the SegWit 2x thing before the certain timeline is acceptable until July pieces. A lot of them being like, yeah, let's make that happen. And so there was this battle between them, and so we were trying to determine what to do. They polled people, and then in order to, as this battle was happening, it was like, how can we actually make this decision? And so what they did is, so part of it is this thing called Bit9, and BIP means Bitcoin Improvement Protocol. In Ethereum, they're called EIPs, Ethereum Improvement Protocols. And when you think about the governance of these things, it's all, in the end, it's like, what happens to the open source software on GitHub, kind of, And so with Bit9, this was this idea that you could add, you could essentially, in a place where not much was being, there was like some data that you could use up here, you could use that little data that wasn't being used, you could use it to signal support. So what they did is, in October 2016, when they said, okay, we're gonna make this happen, we're gonna add SegWit, but the way we're gonna do it is instead of just like broadcasting it to the network immediately, we're gonna use this Bit9 thing and use this field up here that says, only once 95% of the miners are signaling for it, then does it actually go live. And so yeah, that's what happened. They right after that Hong Kong thing, they said, okay, we're gonna do this Bit9 thing, and then none of the miners were down for it. As you can see, this is all the miners in each block that they have. They added this little toggle that said we're into it or we're not into it. And so none of them were into it for a long time, but then eventually, right before this date, we'll see why in a second, it went all the way up to 95, 100%.
About this concept of decentralized governance.
Yeah.
So Bitcoin is a protocol and Bitcoin Core is one implementation of that protocol. Were there other developers of the Bitcoin protocol that were not a part of Bitcoin Core that were a part of this conversation? So when you say they got together and they said, well, we made this decision, since they happen to have a widely distributed implementation, they were, almost making this decision on behalf of everyone because they had the power to do so. Is that antithetical to this concept of decentralized governance? I'm trying to understand how this works.
Yeah, great question. So the way that I would think about that is you have a bunch of these big stakeholders, which are the developers, the miners, the users, and the exchanges / companies. And within and you could either think of them as those big four groups, and that there's some decentralization there. But then within each of those groups, they're not a monolith. And so, for example, with the Bitcoin Core developers, you had, and I think, let's see if this group has, so here, the ones that say core are the ones who were developing Bitcoin Core, that kind of implementation of the software, versus some of these other folks which were doing different pieces. And I think some of them, there were break-offs of people writing different, people call this client software, the software that you run to run a full node, and so that's what Bitcoin Core is Bitcoin Core is the client software that people run, and there were a couple other, back in the day, there were a bunch of other different versions of client software, and now there's just essentially, or almost everybody just runs this main version, Bitcoin Core, but there are, at this time, when people were here and they were disagreeing, as far as I understand it, those people were, it was okay, then you go do your own thing. If you kind of disagree with what the developers think, then we think in this way, and if you want to go do something else, you can go do something else. So this is not only people, as far as I understand, folks who are members of this, who are implementing the Bitcoin Core client software were really part of that group. There are a couple other client softwares that don't really have nearly as much development power or weight in the community, and that when folks, especially at this time, when people the lead maintainer of Bitcoin, let's see if he's here.
Vladimir.
What's up?
Vladimir?
Not Vladimir, but Gavin Andreessen, who was he's not on here, yeah, so that's a good sign. He was a person who was the lead maintainer of Bitcoin Core from after Satoshi until Vladimir. And Gavin Andreessen was very into increasing the block size. And I think as a result of that desire, and him and this other person created this other version of client software that that may have increased the blocks. So this is to say, definitely they're not a monolith. Lots of different groups in here competing for mind share and developer share around both client software and how they think about things.
But also to join that club of people, and I'll call it a club, and Corey calls it a club. It's the Bitcoin Core Club. There are no women.
No.
There are no other minorities that you would. I mean, no, I think there are maybe a few minorities, but I guess there are the representation of the humans that are working on Bitcoin Core that more or less is used by the world is built by a very tiny group of people. Yeah, it's centralized power. It doesn't feel very decentralized at all. And so
yeah, and especially going forward, if there's one group of people that's in charge of implementing the software that then everyone else has to run, don't they ultimately have power to make decisions like these, which are pretty much just implementation decisions that a developer would make?
So, since I would say most of the BIPs, and I think there's 100 and something right now, or most of them got implemented within the first 6 years, and since then it's been like very difficult to actually update stuff within like the Bitcoin spec. So although it's like very like the development power is very centralized, and I think the reason for that is just like market reasons, similar to like why like you don't have a bunch of Intel. So it just takes a lot of like memory power to like create like a really good efficient software or like good efficient hardware. I lost my train of thought. Yeah.
To kind of just to answer that question, developers can propose a change, but then the miners need to accept it.
Yeah, they need to download the new software, but like there's a linear path to these download versions. So if some other feature comes out in a later version that the miners need, they're gonna have to catch up.
Is it linear? Like with Bit9, they initially rejected that, and then they accepted it.
Oh, I mean the path of software development is linear. I mean there's one master branch that's
is
continuing.
It linear? I don't know.
I just think. Oh, so I just remembered. For them to come to consensus at this moment, like it is very difficult. And I think it might be something interesting because there's no Satoshi. Like in Ethereum, there's like a Vitalik, this kind of like central person that can like really push the train of thought as to like how things should go. And what he says is really valuable within like the Ethereum community. There's no like central entity within like Bitcoin that like really has that much pull. So like there's a lot of smart people in the club, but they don't all come to a consensus very easily.
Yeah, I think like I 100% agree with that. Even as centralized as this may seem, it's already decentralized enough to be completely impractical to come to a decision and make any sort of like reasonable change within a like reasonable amount of time. Like it doesn't really happen that quickly, and that's sort of one of the arguments against decentralized institutions is that they're really not as efficient as centralized institutions. But you know.
How cool is that?
Yeah, pretty cool. I think only other, so all that is true. The only other piece of that is in Ethereum there are more in the quantifying decentralization piece. You can see how many different client implementations there are per blockchain, and so I think Ethereum generally has 2 big ones, but right now in their move to ETH 2.0, there's like 7 different ones that are going to talk to each other. So there's that. And then the other thing I would so I think that's the main thing.
And are they parallel streams? So to her point, like are they linear versions like upgrades? So you need are they forced upgrades?
So yeah, and I guess back to the thing of like do the developers and Alex, to some extent what you're saying is like the developers have a lot of power here.
That's what I'm saying.
Exactly.
Yeah.
So I think that is true. I mean, they obviously won here. Like what they wanted was getting this in without SegWit 2x, and they eventually that happened for them. I think that the question for the developers is when they want to upgrade the software, it is the case that the miners need to run the new software that they implement. So they have some power in creating it, but then they don't have any power in like making the miners run it. And the other piece is that they don't, or here are the ways that I would say that the developers have less, or the checks on their power. The software that they create needs to be run by miners. The software they create also needs to be run by the users. And so if the users don't want to, and as you'll see later, there's this thing called UASF, which was this group of people who weren't really aligned with any of the Bitcoin people, but they had just made this new software that could run nodes, and it wasn't really the Bitcoin core stuff that they wanted, but if the economic majority starts to run those nodes, so this is to say that you have to have the miners need to run the software, the nodes, the users need to run the software, and I don't really know how I would think about the exchanges and companies. I think the exchanges have a lot of power in that they determine things like what coins to list and what coins not to list. I don't think they have, so I guess they have a lot of like, once decisions kind of start to get made, I guess they have the main connection to users and things like that through the exchanges. I'm not sure how but I agree that the developers have a lot of power, but they do have checks on their power, which is that they can't force people to run things.
Regarding this check, so let's say developers propose a change, miners don't accept it, and then there's a security vulnerability that is identified, and the developers only solve that security vulnerability on the next version. So that kind of enforces everyone to upgrade, right?
That's what I'm saying.
Yeah.
It's like, okay, I don't want to download Apple's version 7, but when they come out with version 8 that I desperately need, well, I'm going to catch up to everything. And in the way that like Apple has the monopoly on the software for my Apple iPhone, it seems like Bitcoin Core is the monopoly on, to some extent, on running Bitcoin.
Yeah.
Yeah.
I also I thought about your point and I agree to you now.
I'll ask Taj and Corey as well, because I think they're going to make the claim that the Bitcoin Core, the developers don't have as much power, and so I'll ask them. And I think all those things that I said are true, which is that they can't force people, but people, especially if there's a big security bug or whatever, then people got to upgrade to what they say. So I think, so looking at it is interesting to see, so Bit9 was, and this is just to show like how governance happens in these systems, is like they did want to, and the goal for a lot of these developer types is still to have, and for everybody in the ecosystem, is just to keep the stability of the system and to be super paranoid and stuff. And so, because there's a lot of money here, and so instead of just saying we're going to upgrade it, they said, hey, only once all the miners agree, then we're going to activate the soft fork. Then there's this thing called user-activated soft fork, which I mentioned before, and I do want to be clear about these fork definitions. Let me actually write some of the Bitcoin devs. So the fork definitions, the difference between hard forks and soft forks is, so a soft fork is essentially a backwards compatible fork. That's the way to think about it, that you have a, you have your software that's running, I'm running Bitcoin 0.13 or something, and then later on 0.18 is happening, and I can still talk to 0.18 in this way. I might not be able to use the cool new technology that they have or whatever, but I can at least still talk to them. And so that is, this SegWit thing is a soft fork in the sense that there are a lot of people who are using SegWit now and talking to each other with SegWit transactions, but not everybody has to speak in that way. You can still speak in the old way, and it works. So that's the hard fork versus a soft fork. And then a consensus layer fork versus a code layer fork. So when people think about code layer forks, this is like when you have your code on GitHub, you say, oh, I want to create like a new, people often use this when they say like, I want to create a new coin or whatever. And like, okay, I'm going to create a new coin, I'm going to fork it, I'm going to fork Bitcoin, I'm going to call it Bitcoin Reese or whatever, and I'm going to make my new monies. And that's kind of a fork from a code perspective, which is different from a consensus fork, which is when all of the nodes are running with each other, they have all these consensus rules where they have to be talking to each other in the correct ways. And if you have a bunch of nodes over here who are talking this way and a bunch of nodes over here who are talking a different way, well then if they don't align with each other, then that will create a fork in their blockchains, that they will, this blockchain will look different over here than this blockchain because their consensus rules don't match up with each other. And they're like, I don't know what you're talking about. And they're like, I don't know what you're talking about. And so they just go on their own separate systems. So with that, you can see what this user-activated soft fork was. It was BIP 148, and they call it UASF, and that's what people were wearing with the hats. And the idea was that, so there's this thing where that they wanted to make it the case that like, hey, we're the users, we have power in this situation. We don't want you to let the miners decide not to upgrade Bit9. We don't want to let the developers just only do Bit9 stuff. We want to get SegWit in here. And so what they said is, hey, we're going to set this date, August 1st, and if all those miners aren't on board by August 1st, then we're going to run this new software with BIP 148 as a part of it, and those nodes will start rejecting all blocks that don't signal support for SegWit by August 1st. So it's like, I'm this new user, I'm going to implement user-activated soft fork, BIP 148, and if by August 1st, all y'all's miners aren't in on this, then when you try to send me blocks, I'm just going to deny them. If you're not signaling for SegWit, I'm going to deny them. And so the idea was that as long as the UASF is enforced by an economic majority, i.e. their goal was to have lots and lots of users beyond this thing, then this should compel the miners to follow or activate the soft fork. So if you have a bunch of users over here who are like, okay, we're going to do this thing, we're going to reject your blocks, and if there's enough users over there with enough economic activity, then the miners will be incentivized to join that group instead of stay with their own non-SegWit crew. Does that make sense? And so
So
this
when you say users, you mean nodes?
nodes, yeah, and yeah, in
Miners.
general map users to nodes.
No,
and
not minus.
Okay, sorry.
And so as you see here with this graph, unlike this graph, which has percentage of miners signaling support, this one is percentage of nodes that were signaling this. So these ones were again using that diversion field, the little part up there. They're saying, hey, we are all, here's bit 148, we're going to be nodes and we're going to run this new software. And if it's going to happen by August 1st, whatever you do, we're going to us nodes by August 1st are going to soft fork into this new world and we're going to reject all your transactions. And so now what's happening, and of course with all these things, because it's weird decentralized government, there's like BIP 149, which is like a different option that other people were signaling for in a different way.
Why did it jump up and down in this
I
area?
don't know. I think that's probably just a reporting error, to be honest. I don't know.
How do they, sorry, I didn't stop you.
Yeah.
How do they decide what the economic majority is? Is it like at 51% of nodes?
This is just an idea. So there's no definition of economic majority, but it would be something where the miners would look at the system and they'd say, oh shit, looks like almost all of the users they're denying all of our blocks because we haven't upgraded to SegWit. And so like, if all the users are over there, we feel like it's an economic majority, and we feel like that's where, you can imagine also it's like, so I guess to say, there's no definition of economic majority, but it's when they're thinking about their cash flows and how much money they're making, it is the coins that they have, if the soft fork occurs, then they will start to be incentivized to, instead of mine on their old non-SegWit system over here, that those coins might not be worth very much because all the users are on this new system, and they will be excited, and that's where that will be more, that money will cost more than the other money.
What's to stop like these big miners from just purchasing 1 million nodes and just running the old stuff and being like, deal with it?
Yeah, good question. I think so. Well, I guess what you could do is the thing though is that so the question that Lucas is asking is a big question in these systems, which is Sybil resistance, where when you have in our normal reality, when you log in with Facebook or Google or whatever, then your real identification is mapped into your digital world, and that's cool. But what happens when you can just create new random identities, these Sybils, these new bots, and then have them vote for you? And that's the issue. If you imagine any kind of online voting system where you just say one user, one vote, you say, well, how do you determine users? It's just like, if anybody can join, and that anybody is really like just like clicking a button that a bot could press, then the bots will press infinity buttons and beat you in whatever game you're playing. And so for this question, the thing that why that doesn't work here, and this is a weird thing with Sybil resistance, is that so Lucas's question is, why couldn't a miner, if you're over here and you're a miner, you want to just create a bunch of new nodes, you're like, I'm going to create all these cool new nodes over here, and then that will create this, none of them will be signaling for BIP 148, and so we're going to have this like economic majority over here. The issue is that economic majority is about, like if you just create a bunch of new nodes over here, you're essentially just creating a bunch of new things that don't actually have any money-weighted power behind them. And so you have like your miner and like maybe your miner node or whatever, and if you add like 1,000 other nodes, you're not actually adding any additional money over there, you're just adding, the new Sybils don't actually add money to that system, versus on the economic majority side, it's like, even if there are 1 trillion bots over there, all of them, none of those bots have money behind them, while the economic majority over here, all the users, everybody over here has money behind it.
How do the nodes have money behind them?
I'm saying that neither, if you're a miner over here, and let's say I'm a miner that has 1,000 Bitcoin, if I create 1,000 new nodes, and then I say, okay, I'm gonna divide all my 1 Bitcoin among all these nodes, then you still have, whether you have one miner or all those 1,000 nodes, you still just have 1,000 Bitcoin over there. And versus over here, did that explain? Yeah, good,
Are you saying that nodes are always associated with a given address?
I'm not saying that. I'm saying that when you're trying to signal to the network about which fork to follow, the thing that matters is not number of
Total signalers, you're saying it's about economics.
yeah,
My question is, how do other nodes know how much money is behind another node?
yeah. And so in this system, that was not part of this graph. They don't do that, and you can see in a future system, this thing called carbon voting does do that, which is a way to actually vote with money. And this is on Ethereum, where you say, "Hey, I'm going to vote." And when I vote, I am actually going to vote with my money. And in this graph, that this is just total number of nodes, not money behind total number of nodes.
Understood. But still, my question: how are they going to figure out how much money was behind each node's vote?
Yeah. So I think if this were to happen, what they would find is so that there would actually be no. To be clear here, there would be no voting that would occur. If all that would happen is just this, if this were to fire, then all of these UASF people would be running BIP 148 software, and that software would be rejecting the incoming transactions from non-SegWit addresses, like a lot of the miners at the time, and the vote would be a vote of the market, kind of, where you would look at the price. So soon the exchanges would have to start to name these two different Bitcoins different things, and they would start to, and that would be a big thing, which one gets to still be named Bitcoin. And then people would start to then speculate on the prices of these things, and the hope is that when you think about the amount of money behind the nodes, the hope for these UASF people is that there'd be enough folks over here and enough mind share such that the price of the UASF soft fork Bitcoins would be greater than the amount of the non-SegWit Bitcoins.
It's like letting the market decide at that point.
The weird proof of stake kind of thing.
It does have proof of stake flavors. It's interesting. I didn't think about it like that.
But ultimately, are they incompatible? Like, I could imagine a chain that has a 1 megabyte block, and then a 2 megabyte block, and then a 1 megabyte block, etc. And it seems like the only thing that would make this a fork is that there will be some nodes in the in the ecosystem that will say that that's not the type of chain that we accept. But
Yeah, good question.
It does.
So I think that the way that, and I don't know why this is the case, but I'm pretty darn sure that's the case, that in Bitcoin software, when the consensus checkers are saying, okay, I'm getting in some new stuff from the network, that number, that one number or that two number, 1 megabyte or 2 megabyte, it only accepts one of the two. It doesn't, that number's not just like, give me any, it doesn't say like, give me between 1 and 2. I can look into that to understand why that's not true, but you could imagine that version of reality, and that could make sense.
Isn't that a configuration that goes into the block? The size of the payload, like it goes into an HTTP header?
I think it's definitely part of the information that goes into the block, and that then when people are checking, seeing like, oh, is this a legitimately formed block? It's just like, give me either a 1 or a 2, or really give me a 1, and then if it's a 2, it's like, nope, not legitimately formed. And I don't know why. I'll check. I don't know why you couldn't just be like, give me something in between 1 and 2, but they don't know that. So
And that's how you ended up with like Bitcoin and Bitcoin Cash, right? Like,
pretty much Bitcoin, and I think that so Bitcoin Cash exactly was the actual, and you can see in a second. But so what happened is there was around-ish that time that all this stuff was happening. Yeah, nice, perfect timing. The weird thing is all this stuff, I don't know why this is weeks, which is kind of annoying instead of dates, but this stuff was all happening really all right before August 1st. There was the BIP signaling that was happening, and then there was this user activated software. It's like, we're gonna do our own thing as users with the nodes. And then another thing that happened right before it, or like I think essentially around this time, was like these folks were like, you know what, we're just going to go out and do our own thing. We're going to make Bitcoin Cash, which is change that number from 1 to 2. It wasn't like as part of this SegWit 2x thing with this specific new kind of BIP that they were going to use for that. It's just, there's like, no, we're done with all this stuff, and we're going to make our own version of the system over here. And this one was actually, instead of changing it from 1 to 2, it changed it from 1 to 8. And so that's the number they chose. And then this was the market deciding. So this graph is a kind of an annoying graph, but I wish I could find a better graph for this, but this is percentage of total market cap of all cryptocurrencies, so things like Ethereum and Ripple and stuff are on here too. But the idea was that, boom, this fork happened, and then the market was essentially saying like, okay, do we believe in the Bitcoin Cash folks, or do we believe in the Bitcoin folks? And so they were voting with their money and like pouring money into one system or the other system for the one that they believed in. Yeah, so that happened.
Sorry.
And then it activated. So this was obviously the same thing. On July 20th, there were enough folks saying, I wish I could know all the reasons for why this was happening. It seemed like it was consensus among the community. It was the user-activated soft fork. There's a wide variety of things that eventually made the miners be like, okay. And maybe, I don't know if they were able to change their ASIC boost stuff so that they made some kind of new mining equipment that would be okay with this, with SegWit as a soft fork. But it happened, and right in time before people were going to hard fork, and people were happy, or some people were happy. And then in the 2x part of it, SegWit happened, and they were still like, no, let's go from 1 megabyte blocks to 2 megabyte blocks. And then this group of folks that are all the CEOs of a bunch of these big companies that were in the New York agreement, which was the one that didn't have the developers as a part of it, they sent out this email. Everything happens on the mailing list. And they sent out an email that said, yo, like although we strongly believe in the need for a larger block size, there's something we believe is even more important, keeping the community together. Oh. Isn't that nice? And so they say, and so with that in mind, unfortunately it's clear that we have not built sufficient consensus for a clean block size upgrade at this time. So this was November 8th. So this was after August, September, October, and then November. They were still trying to like, let's make the 2x happen, and they're like, nah, it's not going to go down. So they gave up. So that was a history of what this governance looks like in these systems, and you can see as a part of this how Bitcoin does its sense making with in-person meetings, with technical checks, with various like polling important people, how they eventually do the decision making with like these wide variety of BIPs primarily to be like, okay, let's get 95% of the miners to activate, and then the incentives and power of different stakeholders, and how one other thing I just want to add here is that a lot of what we talk about is like the incentives of different stakeholders, like how money is a part of it. But there's also, and like also the code piece and how code is a huge part. I think the norms and law piece though, I just want to re-emphasize here, which is that I know folks in the Bitcoin world who felt like the community didn't have clearly defined norms at this point, and like by being more pro-decentralization, by being also very still paranoid and taking things slow. And the folks who were less into that were able to go and do their other things. The people who were more into internet payments could go and do that in Bitcoin Cash. They felt like they got more coherence as a community as a result, and that those norms were kind of re-emphasized. And all of that was, again, connected to the law piece here, which is that this difference between can't and won't, and the desire for the for only, like if the government were to come and say, hey, you must do X, Y, Z, well, what they showed is they're like, look, if you want to do X, Y, Z in this Bitcoin community, you gotta talk to the core developers, then you gotta talk to the miners, and then you gotta talk, and like, so US government, if you want to make this happen, like, good luck, but like, it's gonna be a can't kind of scenario. Yeah, so that is this debate. So after reviewing that, does anybody have any, we've been chatting about it throughout, but any like thoughts or questions or things about how the governance happened in this bottom-up way?
Is there a question about your own personal opinion, Reese? Do you see this governance being like effective enough to be able to keep up with all the changing technologies around the space and be able to continue making Bitcoin the sort of benchmark cryptocurrency, or is it just going to be too slow to adapt and something else is going to kind of like?
Yeah, good question. So the question is like, this is obviously a slow process. This is similar to IPv4 versus to IPv6 thing. Like, it takes a long time. I think that, and Bitcoin right now has about 70% of the market cap of all of the other cryptocurrencies. I think that this system is very good for if you want the money to be a censorship-resistant store of value, doing things super slowly and really getting not even rough consensus. This is not rough consensus and running code. This is like full consensus and like don't deploy any, like not move fast and break things. So yeah, I think it's a strong evolutionary niche in the cryptocurrency world that, and I personally think that there's going to be a bunch of other ones that are happening that will be more in the move fast, break things mindset. And I don't know if long term those things will eventually have more of a market cap than Bitcoin. I mean, I personally think in 25 years I would be surprised if Bitcoin was still the top, or even how we think about money at that time. But I think that for their niche, I think that all this makes a lot of sense. The paranoia and chillness. Are we good?
Just like I like another example of like the hard forks of like Ethereum and Ethereum Classic, for like different reasons. Like the Ethereum Classic is like the purest people that believe that you shouldn't have changed anything at all, and then the implications of like the current Ethereum are like a lot more flexible as opposed to Bitcoin.
Yeah, and I think that your point there is back to this norms piece of like, hey, and this gets into this the Ethereum example of the DAO. And just to check with folks this is like, super what happened in the DAO, everything. This is like, you don't really know what happened with the DAO. Okay, so more than the Bitcoin. The idea behind the DAO was it was in 2016. It was on Ethereum, which is a different platform that does smart contracts. And what they were going to do was have this new venture capital kind of fund, a new smart contract that a bunch of people were going to put their money in and then vote to fund different things in the ecosystem, or just fund whatever they wanted. And 10% of all ETH went into it. It was $150 million at the time, and there was a bug in the smart contract, and that bug allowed someone to drain 50 million, so a third of the funds from the smart contract, and get it. And then once that happened, then the community was like, oh God, like, what should we do here? Should we allow that $50 million to just go to whoever this random person is? Or should we do a hard fork and rewrite time? And here's your blockchain that's going, and you're like, oh, let's just go back before any of this happened, and let's make it the case that none of it happened, that the DAO didn't exist as a thing, and that the funds were not drained. And so the community did a bunch of similar kind of determinations. And decided to fork. They said, or they decided to move back time. And when they did that, and back to what Daniel's point is a bunch of the folks were like, no, we don't want to just like move back in time. These were what people call like the code is law people, where it's like the code was what the code was, and like whatever happened happens.
Write better code next time.
Exactly, write better code next time. And those folks forked off to be Ethereum Classic, and Ethereum Classic has more of and the folks who are there are more of this code is law, be super, kind of closer to Bitcoin perspective. It's like, no, we want to keep things super chill, while the current Ethereum crew is more of just like, let's like rock and roll and like do whatever. And like, if something like the DAO happens, again, we'll just refork it out. It's not entirely true, but that's to some extent true. And so there was more coherence in the system kind of after that fork happened.
Do you feel like a hard or soft fork one is better than the other, and like why? Or would you say like depends on the scenario and like in what ways do you think it would be okay to use one over the other?
Yeah, good question. So I think, and I think soft fork is a bad term. I wish it was just called like backwards compatible upgrade. And so in general, I think
how does that work?
the way that the soft fork works is it just says essentially just you can imagine it's just like it adds a piece of essentially imagine it's like adding additional functionality to some nodes that doesn't break the functionality of the old ones. So I think that's in general the way to think about it. You can also think about it as taking away a little bit of functionality with new nodes, but if the other nodes try to send it to you, you just like ignore it, or like whatever. And so I think that soft forks, in general, definitely depends on the situation, but I think that soft forks, in general, the folks believe that soft forks are better, that you should make these backwards compatible upgrades. Because if you hard fork, it just creates a lot of confusion for everybody. Because like with all these things, all the exchanges then had money. Now they have twice the amount of money. They both have their Ethereum and Ethereum Classic, or their Bitcoin and their Bitcoin Cash. What should all the exchanges name all of them? Like, okay, they had to create a new 3-letter ticker. Like there's BTC for original Bitcoin, and now BCH for new for Bitcoin Cash. And so it just creates a lot of
Versus like with a soft fork, you would just like still have Bitcoin, but the rules of how the blocks are interacting with each other changes.
exactly. Let me think of it. Yeah, it's like
What's an example?
an example of a soft fork that is easy is, let me think. There was one that just like increased this was old and in Bitcoin. I'm trying to remember what exactly it did, but essentially it was a way to it was like a new like transaction format or something that when you I wish I could remember the exact specifics, but essentially the new nodes, what they did is they would just send both the old version of reality, or actually let me give you a good example. There's this thing that Taj does called UTreeXO, and the way that UTreeXO works is it collapses the size of these nodes, of Bitcoin nodes, from 4 gigabytes of like transaction history to like 4 kilobytes. And it collapses it into this like essentially a proof of the system, where you're like, okay, I now have just this one thing that's a proof of everything else. And his thing works with a soft fork. It is a backwards compatible upgrade because the code for it, the way that it runs is when you're trying to talk with people in the system, you both send them the proof version of stuff and you send them the old school version of stuff. And so if you're a new person, you're like, ooh, what am I looking for? I'm looking for new stuff. Oh, sweet, give me the new thing, the new proof. If you're an old person who hasn't upgraded since 2010, then you could still be like, oh, just give me the old school stuff. Oh, I can still see it. Okay, cool. Yeah, so I would even say, instead of soft forks, always replace backwards compatible upgrade with that.
So when you like a Bitcoin Cash hard fork, so you have once initially hard fork, you have both. You have double the money.
Yeah.
So, but does that impact the value compared to US dollar?
Yeah, great question. So, and this is a question that people in the cryptocurrency world ask, which is, are forks value producing or value decreasing at a macro level, where you're like, okay, there's this new fork, and you think kind of that you're like, oh, if Bitcoin was worth $1,000 before, now you have Bitcoin and Bitcoin Cash, maybe it'll still add up to $1,000 now, or maybe it will add up to more than before, or maybe it'll add up to less. And generally what people found is it adds up to more.
So why don't you fork it again?
Exactly. And obviously it depends on how much, but you can think of it as like, with like this as an example, there are enough folks that are into Bitcoin Cash. Essentially, you can imagine it's like from a macro omnipotent perspective, more coherence. This system has more coherence than this system had. This old system was like, you had all this fighting, you had these people, you didn't really know what the hell was going to happen with the future of Bitcoin. You had these people who were arguing with each other. And now you have a new world where you have this very coherent Bitcoin Cash folks who are trying to make internet payments. And you have this new super coherent Bitcoin Core folks who are trying to make a censorship resistant store of money. And yeah, there was this idea made a Bitcoin worth $1,000 before, but now in this new version, you know what, maybe it's worth $2,000. You know, $500 for Bitcoin Cash and $1,500 for Bitcoin, because there's more coherence in the system generally. So this is very difficult to determine, but empirically speaking, especially for forks that were the result, not just like, when people just make random forks, if like I made Reesecoin, that would be a non-value generating thing, that would have no value. But for things where it's lots of big communities doing things, then those things generally shouldn't be value creating.
Do you think like Ethereum would have rolled back time if Vitalik, Vitalik was like said that it should happen? So like, do you think it would have happened if he had said that it shouldn't happen?
Good question. So, and this gets to with the tyranny of structurelessness things. I think that Bitcoin is in a scenario where it's harder to gain consensus because they don't have what these projects often call the benevolent dictator. So with Linux, it was this dude Linus. With Wikipedia, it was this dude Jimmy Wales, the person who always asks you for money on Wikipedia. And in Ethereum, there's this person Vitalik, who's one of the main creators, who's like kind of the figurehead. And I'm not. I think that Vitalik had a lot more power a long time ago. I think that he has actively been trying to decentralize power away from himself now. So I'm not sure if in 2016 if he would have been against the hard fork. I think that there's also a question of if he was against it, and then what are all of his arguments? Because like just being against it's one thing, but then having a full set of like good arguments that you could talk to everybody about, then everybody's like, oh, those are legit. But if he said it and had a bunch of arguments that he thought were legit and no one else thought they were legit, it would be tough to tell. But I would honestly expect the community to, if they didn't, the people that were, and there are a lot of serious people that engage very seriously with all these decisions, and so if they thought that the arguments were not legitimate, I think that they would not do what he thought. Yeah.
Technical question. Do a whole bunch of soft forks eventually become a hard fork? Like, do you have to make it so that it's always backward compatible to like the first version of Bitcoin, or can you just go up to like 5 versions ago, or like the version of 9? I don't know.
Good question. So the question is, soft forks are usually thought of as backwards compatible, at least one back, and then the question is, how far back do you go? I think so. I don't know the answer to this question. I think that it is fully backwards compatible. Is I think the answer.
So there's a limit to how many how much you can do with a soft fork.
Because it has to still connect with something from 2012 or whatever. Yeah. So we're getting into the round, but we have about 15 more minutes left. So I want to, let's chat for a second about on-chain voting as a thing. Because a lot of what we talked about, in the Bitcoin world, none of that was on-chain voting. There was on-chain signaling, where miners could signal their support, or nodes could signal their support, but there's never on-chain voting. And so there was let me see one final thing. This parity multisig one was like another smart contract issue where people lost at the time it was like 160 million or $300 million worth of money. It was a lot of money, and then we were, and you go, this was one where I was now actually part of the crew at that point, and so we went to this thing EIP0, which is, there's no EIP0 that exists, but it was like a crew to talk about governance. And it's a bunch of people sitting around being like, I don't know, should we do it or not, and there's a lot of yes and no answers to that, but that money has not been returned. So you can also think of a difference in time, like this money was returned because it was 10% of all ETH at the time, and this money was not returned because it was a high percentage of the money and possibly other reasons. So in any case, there's on-chain governance is, let me say one final thing about this is connected to both on-chain governance and on-chain signaling, is that when you have, so this is a thing I referenced before called carbon voting, which is where you take your ETH and use it to vote, and so this is, instead of just single address, single vote, this is ether-weighted voting or money-weighted voting, where it's like the amount of money that you put in determines the size of your vote. And as you can see here, when they were doing this vote, this was for the DAO, of all the ether supply, it was only whatever, I don't know what the actual percent was, 6%, 10% or whatever, that actually participated in the vote. And then of the people who did participate in it, a huge percentage was just one person. And so this shows some of the issues with some of these signaling mechanisms. And when you think about on-chain governance more generally, so the idea here is, and something like Tezos does this. So Tezos is another smart contract platform, kind of like Ethereum. And the main difference for what they do is this thing called inflation funding. Inflation funding is the idea that when you're trying to determine what new code to add to the system, the way you do it is we're waiting to see what new code we should add, and someone, as part of the crew, says, ooh, what if we added this to the system? What if we made the blocks bigger or whatever? and then everybody votes. I think in a coin-weighted way. Everybody votes and says, "Okay, do we want that to happen?" And then if it does happen, then that person makes money. You increase, it's called inflation funding, you increase the supply of Tezos. You essentially print new money for that person and give it to them. And so if there was 1,000 coins in the system before, and then I say, hey, I'm gonna make this new change, it's gonna be awesome, and if this change happens, I think you add a amount to it. You say, let's do it for 100, I get 100 coins for doing this. Everybody looks at me and says, that's pretty legit. And we have a voting period, and then we vote, and then if it happens, then it's like, oh sweet, it happens. And then, even though there are 1,000 coins in the system at the beginning, then 100 new coins get printed for me, and then I get them, and which decreases the value of everybody's coins just a little bit. And then that change gets upgraded to the network. Does that make sense for how that operates?
Mm-hmm.
And so that's an example of on-chain governance, because it's a way of saying all that just happens on the chain kind of automatically, and you can use some of the off-chain signaling, but in the end, it's just like if the vote happens, it happens. And so the big issue with it, so it's exciting because maybe you could do things in a more efficient, autonomous way to some extent, but there's a quote from something like anything else put directly in your code can be exploited or gamed more quickly and easily if flawed. So kind of like with the DAO, there's an issue with it, and it's like, oh god, this is bad. You can imagine on-chain voting things that if you find out ways to game them, then they could be really bad. And so there are, and when people game things, they really do, this is a picture from one of the Vitalik posts about like, people game things even, people will try to game systems even when the money is not as closely baked into it. So this is a bunch of smartphones that it's like a click farm. So people are, just smartphones running and clicking on things. And then this is a thing that's like that, but instead it's just you want to buy followers for accounts. And you just pay this like Russian account or whatever to buy followers. And so, yeah. Don't believe what you see on the internet. And so we expect similar things, but even more aggressive things with on-chain governance, essentially. And so what you see is, and as I talked about before, there's this balance between identity and Sybil resistance. And you can see in this situation, this is a non-Sybil resistant system where you can make Sybils, aka bots, aka non-humans, just run a bunch of smartphones and do the clicking for you. Or over here, you can buy a bunch of followers. Are those real followers? You go, humans? No, they're just like bots operating, maybe in this farm or somewhere else. And so that's why there's this a very difficult thing in these systems is that if you want to do on-chain governance, it's very difficult to do one address, one vote, because that is a non-Sybil resistant system, because then you can just create infinity addresses and then like vote. And so, or in that system you can then strongly connect identities, and that's possible, and that's what some of these, that's like KYC and AML or whatever does that. Or what you can do, a Sybil resistant system is coin voting. And that's kind of what we were talking about before, where it's like, if I have 100 ETH and I want to vote for something, and I'm like, oh, I want to vote for it even more, and I create a bunch of other like addresses or fake accounts, that didn't really help me that much because like I still only have the 100 ETH, and so I can't like even if I divide that among everybody and then they vote, like it's still 100, whether it's just in one account or in a lot of accounts. But then when you have those systems of that are Sybil resistant, like coin voting, then that leads to things like plutocracy, which means the people who have lots of money get to do whatever the hell they want.
There are some sort of financial incentives to like screw with the network if you can get like short positions on the network and then just borrow a bunch of money and make terrible decisions so that value of the coin goes down and then you make a bunch of money on that value of the coin going down.
Got it. Yeah, so what Lucas is saying is that what you can do is you can, and you can do this for any network, where it's like if you can create, if you can do an attack on one of these networks that you think will decrease the value of the coins of that network, what you can do is short the coins on the network, where you say, you essentially make a bet that says, I think the coins are going to go down a bunch in value, and then you do your attack on the system, and whether that is a proof of work style attack where you get 51% of the miners to attack it, and then and everybody's like, I'm very scared, or whether you do a proof of more of like a coin voted or proof of stake style attack where you again make a bunch of Tezos proposals that are really bad for the system, and then at the end you get to make a bunch of money because then Tezos goes down in price, or whatever you did goes down a lot in price, and you shorted it beforehand. So that's the idea there. So so that's on-chain governance. I think so I think let me see two final things. So talking about DAOs and then the ethics of this stuff. I think from a DAO perspective, so as a reminder, a DAO is a decentralized autonomous organization, which is just like a smart contract that's running on these networks. And you can think of it as a form of on-chain governance. When people talk about on-chain governance, they're usually talking about the protocol layer. There's like the governance of the underlying protocol, while DAOs are usually not at the protocol layer. They're at the application layer. They're a kind of smart contract that is running. And just as an example of one, this one called Moloch DAO is an interesting example. It's very similar to the original, the DAO. And the way that it works is it has a not really complicated mechanism, but essentially you put a bunch of, if you want to join this system, there's like a pot of money here, and anybody can offer to be like, hey, I want to get in on this, to join this pot of money. And you make a proposal to like join the crew, essentially. And when you join the crew, you have to offer like a tribute. So you say like, hey, I want to join the crew. And usually what that tribute is just more money into the system. So you say, hey, I'm gonna like add 100, I'm gonna give 1,000 ETH to be part of this, and I want to be part of this crew. And then as a result, I'll get some of these like Moloch DAO shares. We'll call these like DAO tokens. And so I say, hey, I want to be part of the crew, and then as a result, I'll get 1,000 of these DAO tokens. And then all the other folks who are already a part of the system say, okay, do we want to let this person in? And we say, maybe, maybe not. And then a vote happens, an on-chain vote happens, a coin-weighted vote. And then that person, let's say they get in, then this amount of ETH goes up. Let's say it's now whatever, like 9,000. And the reason this system has been running for 6 months now, 6 to 12 months, it has not had any smart contract bugs, which is nice. And what they do with the system, I can even go to Moloch now. What it does is here's my mad mask. Oh no.
This is like, if anyone is like on Twitter right now looking at Moloch DAO, they have like a poem at like the header. Yeah. It's fascinating. You read it? Moloch whose mind is pure machinery. Moloch whose blood is running money. Moloch whose fingers are 10 armies. Moloch whose breast is cannibal dynamo. Moloch whose ear is a smoking bomb. Tomb, smoking tomb.
What's his name?
Alan Ginsberg wrote the Moloch Sparta Powell.
Wow.
The second or third.
Yeah.
Fascinating.
Yeah,
Is that the original one or is that adapted?
I don't know. I think he might have adapted.
I don't think that's Ginsberg's.
It's a remix.
Yeah, it feels remixed.
The GP2 also did a wonderful rendition of its style.
That's funny.
And,
Right.
and this is
And this is the site where you can see it's running. It's got 1.2 million bucks in it, and
it's USD.
that's USD, yeah. And you can see there's a bunch of different there's both members who are part of the system, who are all these random like.
You just can't take yourself seriously.
It's
beautiful.
Or they're just like huge.
Good question.
Like there's so many different types of DAO. I feel like.
Yeah. So Natalia's question was: are there? There's Moloch DAO, which we're talking about here, and then there's Maker DAO, and they're similar in that they use on-chain voting in order to keep the health of their systems, but they're different in that Maker DAO, its goal is to. So the way that it's voting, we don't need to go too deeply into this, but the Maker DAO, they have the DAI stablecoin, which is supposed to be close to $1, and then there's the MKR, which is their governance token. And so they use, essentially the way to think about it is this MKR token is the way that they determine how much to charge for fees in the system, essentially. And so it is a DAO in the sense that the MKR holders do vote occasionally in a coin-weighted way to determine the fees of the system. And that's different than something like Moloch DAO in that Moloch DAO still has this coin-weighted voting with their their DAO tokens or whatever, the Moloch shares. But instead of voting on these makers voting on how to makers voting on the fees of the system, and they're trying to keep this DAI stablecoin stable. While over here, there's no stablecoin that's connected to Moloch DAO at all. It is just they have this pot of money that $1.2 million, and they're trying to determine how to spend it.
They're just like a VC.
They're kind of like a VC, yeah. And so they have these members who vote, and then they also have these proposals, and they fund proposals, and almost all these proposals are things like things to increase they're like development proposals for Ethereum, like, hey, let's give this person money to like code up a new client or whatever. Does that answer your question? So they both use on-chain coin-weighted voting, but the goals of them are very different.
Is it all philanthropic like that, or do they do investing?
Good question.
How
So
can I trust the people? Like, I don't know.
yeah, well, so from a trust perspective, a lot of people who try to get into it don't get accepted. You have to essentially be like, hey, I'm a legitimate person from the Ethereum community. And the goal of the Moloch DAO specifically is to fund cool Ethereum research. And so you have to, that's what the whole system is designed around. And so the people who are voters in that know a bunch about that. The proposals that happen only do that. And so for this system, it's all philanthropic in the sense that it is essentially people with a lot of ETH that want to see ETH go up in value later. And so they want to fund these new proposals such that the system is successful later. But there are this DAO format, the Moloch DAO system, the way that it works, it has been forked in a bunch of different ways. And so there are probably 10 or so Moloch DAO variants that exist right now that do different things and are optimized for different things.
And then there's like futarchies that are a different type of DAO. Like,
and I would say that futarchy is not a different kind of DAO, but it's rather a different kind of voting system. And so when you think about all of these use coin-weighted voting to determine like, hey, here's this option, what do we want to do here? And you just vote with your coin-weighted. You say, I'm going to put a bunch of ETH or whatever. That is futarchy, and we don't need to go too deep into futarchy now, but futarchy is it doesn't necessarily need to be a DAO, but it is a way to make decisions. Instead of voting to determine whether a decision will happen based off just like coin-weighted voting, you instead determine whether the thing will happen based off people betting on it. And so the betting market determines the answers rather than the coin-weighted voting determines.
but if that's like programmatically put, where like if someone votes into something, then like that's what happens. Like, isn't that like just like a DAO, just not in the same flavor of MakerDAO or like a Moloch DAO?
Totally. So what I would say is, yeah. So if you take that futarchy, so you can. What I would say is, I'll do this, and then I think we should wrap up. There are coin-weighted. So this is like how the actual decision gets made, coin-weighted versus futarchy versus liberal versus like a couple other different ones, and that's different than if you put the thing on the interwebs, then it's a DAO.
Okay.
Kind of. If you put it on like a smart contract.